Okay, we're going to start off with all the mistakes that Aristotle made. So he was a guy who came up with the idea of forces acting on objects, or at least he wrote. He's one of the earliest ones who wrote about it, and he says that two things. I'll write them down here. One, the natural state is rest. So he's looking at objects around himself and he's noticing, hey, things aren't just floating around unless something's acting on them. So normally things are just resting. And then movement comes from a force. Okay. And then a force now is a vector. So it has a direction and it has a magnitude. So the direction is where is the object being pushed to, the magnitude is how much is it being pushed. And the way he wrote it was that the velocity, your speed kind of, is proportional to the force. So if you were to graph this, as a force increases, your velocity increases like this. So if you're applying b amounts of force, then you're applying this amount of velocity. If you're applying a amount of force, you're applying this amount of velocity, which is smaller because the force is less. And if you are applying 0 of force, there is 0 velocity. Okay, so this makes sense because if you imagine yourself like pushing an object, here's my picture. The book is always using a refrigerator here, so that's my refrigerator. And I have me standing here pushing that object here. The more my force, the bigger my force is, the faster that object is going to move. Okay? Well, there are some flaws here, and I'm going to draw a couple little figures here. First of all, just think about a ball being launched up in the air. So, when we think of objects flying in the air, we're going to be calling it projectile motion. And here's the issue. Aristotle's philosophy says there is a force being exerted on this ball right here all the way until you let go of it. Now, in our experience, a ball will come up, come down, and hit the ground. But here's the deal. The force here being applied works just until you let go of the ball. Now, according to Aristotle, if your ball is right there, there should be absolutely no velocity, no speed, because there is nothing pushing it. But somehow when you push a ball, there is an amount of speed that is still in reserve, kind of. And so at every point it's in the air, it shouldn't be moving according to Aristotle, which was one serious problem. The other was dropping a ball, a free fall situation. If I am standing up on top of a tower like this, and I'm holding a ball out like this, now if I let go, we know the ball is just going to start dropping to the ground. Now the issue here is that I am applying no force to the ball ever. And so according to Aristotle, that is this situation here, where we are applying no force, there should be no velocity. But clearly, if we just let go and apply no force, that ball is going to drop and go faster and faster. So that is just kind of a history of force and movement. And that is also why we can't just say that whenever you apply a force, you get speed. Because it's a little more complicated than that. And another note here that the book talks about a little bit here is Galileo. Speaking of dropping balls here, Galileo was first to show that if you drop two different sized cannonballs, you're going to have them drop at the same rate. Now Aristotle noticed that things that are heavier, things that are lighter, tend to drop at different rates if you were to drop them, but he wasn't taking into account air resistance. So Galileo showed that it's not a if you ignore air resistance, if you have two different weights, they will drop at the same rate. And so it's not actually, it doesn't have to do with the mass so much. Okay, so what we're going to do now is we're going to start talking about motion, and we're going to try to relate forces to motion. So it's not as simple as forces just creating movement. Forces also have to do with velocity and something called acceleration, which we will go into now.